When you're up there mining coal, we now have to have 8,500 CFM, not 7,000. Another catch, if you look on there, that right hand or left hand column, it says 60 feet per minute mean air. Anybody know what mean air is? CFM is cubic feet per minute. That's technically how much air is passing through an area in a minute. Mean air is technically how fast it's going. Just feet per minute. And so if you've got, say you got 7,000 CFM going through an entry, and that entry is only 4 feet high, that air is going to be traveling pretty fast. You got an area, an entry that's 10 feet high, and you got that 7,000 feet per minute going through there, it's not going to be traveling very fast. It's the same thing you'll find. You get a garden hose, you got a sprayer on the end, you can adjust that down to make a real fine stream. It's not a very big stream, but it's going a lot faster. If you open it up, it won't spray out there near as far, but you'll have more water going through. And so, when you talk about 60 mean, they're saying you've got to have the air moving fast enough to move your dust and everything away. You get a bigger area, you're going to have more air. But again, they've changed it, so we got 8,500 in the face where the miner's cutting. At the intake end of a pillar line or the last open crosscut, if it's over 7 feet, we got to have 1,500 CF or 15,000 CFM. If it's under 7 feet, 9. And again, that's because of that mean air factor. If you're only 7 feet, if you're under 7 feet high, we don't have to have near as much air as we do if we're higher. It'll seem like more air, but we won't have to have as much. Roof bolting face, again, that's where the roof bolter is working. Again, this is being changed, that under 7 feet has been taken off, so any place the roof bolter is working, we got to have 3,000 CFM. In an idle face, that's a face that's been cut, nobody's doing nothing. There's nothing going on in there, we got to have 1,500 CFM, which is hardly detectable, but we got to have air moving. Okay, this is the location of the ventilation control, which technically right now is our Bradis line. In a bolting face, where the roof bolter's in there, that Bradis line has to be at the out by end of the roof bolting machine. In other words, that Bradis can't be back any further than the back of that roof bolter. If you've got a place that's been bolted, it's idle, it's got to be within 20 feet of the face. If you've got an unbolted face, then it's obvious you're not going to put it in 20 feet from the face. It's got to be up to the last row of bolts, really, up to 40 feet. If the place isn't bolted, but it's partially bolted, say it's not bolted for 30 feet, the Bradis still has to be up to that last row of bolts, so you get up to 20 feet. You got a working face with a spray fan or scrubber system. What we're talking about is in there with the miner. Our miners use a scrubber system. Got a big blower on the side of it that sucks the air back through it. The Bradis can't be any closer than 5 feet to where that scrubber blows the air out. And it can't be any further away than 15 feet. What this does, if you put that Bradis up closer than 5 feet, what it's going to do is blow all the stuff back on your shuttle car operators. The scrubber won't blow it behind the curtain. You got it too close. So you can't get it too close, but you can't have it too far away. Now if we're using what we call a fan spray system, and what that is technically is we got sprays on the miner that will all blow to the left side. All the water sprays will blow in one direction. If you got that system, working, which we do have them on our miner. If the scrubber quits using, we will switch over for that. But if we're using the directional sprays or fan spray system, then it's 40 feet where Bradis can be. If we're using the straight sprays, we can't cut 40 feet. The Bradis head can't be no more than 20 feet from the face. Minimum ventilation requirements for diesel-powered equipment. At the section loading point where the Gale or Bobcat scoop is being operated, the air measurement will be taken in the crosscut on the intake side of the loading point. Now, you see where the feeder is there. A lot of times we'll have a Bobcat in there and we'll keep that feeder clean. Now, first of all, if you got the Bobcat running, again, I told you have a little tag on there that tells you how much air it has to have. I believe on the Bobcat is 3,000 CFM. So where you take that crosscut, or take the air reading, is the crosscut just in by where the feeder is, on the intake side. You gotta have at least 3,000 CFM going through that crosscut. If other diesel equipment is operated on the working section or where mechanized mining equipment is being installed or removed, the minimum requirements for the last open crosscut or intake in of the pillar line will be combined air requirements of the approved plates of the equipment plus the minimum last open crosscut requirement. So you start bringing a lot of diesel equipment in that section, you're going to have to get a lot of air. And we're going to be going, when we get this long wall going, like we're going to file for a petition right now where we'll just have 2 entries going into that long wall. Which means our belt line will be in the return while we're developing, when we're actually running the long wall, the belt line will be in the intake. But the bottom line will only have 2 entries. There's a lot more regulations, especially for ventilation, they make us follow. Now each miner we have has a totally different plan. We've tried to make the miners look the same, designed them the same, but each miner has its own plan. And this just shows you where the sprays have to be. We got to get everything approved by MSHA. We actually have to, it shows right there up on the top, you got 12 sprays that spray across the top of the bits. You got 3 on each side, 2 back there ways, 3 in different blocks, but it shows you every place the spray will be. So there's no question. Plus that shows you where we got the scrubber inlet. The scrubber has a spray inside of it. It's got a screen in there where the scrubber discharges. Everything's got to be approved and submitted to MSHA. Okay, the dust suppression on the miner, again, each miner is different. This is kind of an example of our miners. The sprays we have on there, they've got different sprays, and they got the different sizes, what determines how big the hole is in the spray. We can use a number 2 or a number 3 spray. Total number of sprays on this machine was 31. The minimum spray that have to be working is 28. Minimum operating water pressure is 100 psi. That's why all the sprays are working. You got to have 100 psi. In the scrubber spray, you got to have 50 psi. The scrubber shall be used with conventional spray pattern. 90% of the listed operating spray shall be working. In other words, you can have some sprays can be plugged. But any spray bank, when you looked on there, it had some that had 2, some had 3, some had 12. Any that have 3 or less, all of them have to be working all the time. So what we normally have to do, we'll go in there, we'll check the miner out, make sure all the sprays are working. They'll go in and they'll cut a place 40 feet, they'll back it out, they'll check the sprays. Most of the time you'll have 1 or 2 plugged up. You get them cleaned, go cut the next place. Sprays on the miner will be checked prior to each cut. If the scrubber stops working, deep cuts will be discontinued. In this case, the maximum ventilation device setback will be 20 feet. And again, we've got on our miners now, we have that directional spray system, so we can still cut 20 feet or 40 feet. Once a breakthrough has been made or during retreat mining and the air is coursed over the miner, the scrubber may be turned off. Again, this would be when you're not using a Bradis line. The air is going over the top of the miner and up in the gob or straight through the crosscut. The scrubber will be switched off while turning crosscuts to avoid dust blowback. And again, if you've been in there when they're mining running a shuttle car, he's turning real hard to the left trying to make a crosscut. If you're on that shuttle car and he turns that scrubber on, you're going to get buried with dust and water. The scrubber shall not be started while the cutter head of the miner is in the fully down position. This is the real problem for us, that they've had a lot of mines that are real gassy. You got that head clear down against the floor, up in the face, and you get a methane buildup underneath the head of that. We've had a couple of times when guys have turned that scrubber on, and they've had a problem back in the scrubber, and they've actually caused an ignition explosion in the scrubber. So you got to lift the head up and let air swoop around there and clean any methane out. The scrubber shall be de-energized and all operations stopped while taking entry air measurements. In other words, that air we was talking about, we got to check, make sure we got the 60 mean, check, make sure we got 8,500 behind the Bradis. The scrubber's got to be turned off while you're doing that. The air volume at the face will be checked prior to cutting coal. The flooded bed scrubber is rated for 6,000 CFM air, and their readings at the scrubber exhaust will be taken during each production shift. If the quantity falls below 6,000, corrective actions will be taken. Again, we got to check that scrubber. Actually, the scrubbers now that we're using, we just got 2 brand new miners. I think they're rated at about 9,000 CFM. But we still got to where if it falls below 6,000, we got to fix them. Flooded bed scrubber screen will be cleaned and or changed twice per shift as per manufacturer recommendations. Again, back in that scrubber, it's got a screen back there that water sprays on, and that's what knocks all the dust down. We got to pull that screen out and clean it. Flooded bed scrubber will be cleaned and flushed once during each 24 hours of use, or more if necessary. That's all the ductwork on it needs to be washed out. The line Bradis will not be advanced in by the last well permit support. The Bradis will be located on the same side as the scrubber discharge. Now we've got a miner coming, supposed to be here this week. Everybody's always used to seeing this Bradis on the left-hand side of the miner. We start pushing this gate entries, these new entries. The Bradis line will be on the right-hand side of the miner. The scrubber discharge will be on the right-hand side of the miner. It'll be a little bit different than we're used to. Each miner may have a different spray arrangement and number of sprays. Ask your supervisor which miner you are running and become familiar with the spray arrangement for that machine. Okay, we got any questions on ventilation? Again, ventilation is one of our weak points. It shouldn't be. We have some of the best equipment in the world, bar none. There's nobody, I'd have to say, that has any better equipment than we do. And I believe we have smarter people than they do. Sometimes we outsmart ourselves.
Is there a difference between a stopping and a seal?
There is a big difference between a stopping and a seal. A stopping technically is a single row of blocks, and again we're using Omega blocks. We're dry stacking them. There's just one single row of blocks we stack up, put sealant on them. A seal, if you ever get a chance to build them, we use solid concrete blocks, and they got to be too thick, usually with a pilaster right in the middle. Every course has to be mortared, every seam has to be mortared. They've got to be hitched into the floor 4 inches, into the ribs 6 inches. They're an awful lot more work. But they are, what they do with, we do with seals, is we seal off areas that we don't plan on going into anymore. And you have a potential of having an explosion behind them like they found in the Seiko mine. Now one thing, when we're building stoppings, I'm sure you guys will get plenty of practice doing that. We've had some problems with not building stoppings properly. We're doing 2 different types of stoppings now. We're doing of course, the Omega block stoppings, that most of you are familiar with. And we're doing a Kennedy steel stopping, made out of metal. When you build the Omega stoppings, they have got to be level, straight. These Omega stoppings, when we put them in, they are going to be there for a long time. If they're not straight, they start taking a little bit of weight, they just pop out. As you build the stoppings up, again, we just dry stack them, we don't mortar them. We stack them up to the roof. Once we get them to the roof, we wedge them in good, and then we put sealant around them. When you're stacking them, the main thing is